Today we are finishing up the DHO Chapter 1, and this is the fifth day of the lessons, and today we're going to be talking about pandemics. So pandemics exist when the outbreak of a disease occurs over a wide geographic area or affects a high proportion of the population. So there's a difference between a pandemic and epidemic. Epidemic is over a smaller geographical location, whereas pandemic affects a very high portion of the population in a very big geographical area. So that's the difference between the pandemic and the epidemic. Pandemics are a concern. There's a concern that worldwide pandemics will become more and more frequent. Because people can travel throughout the world, disease can spread much more rapidly now. So yes, it is very nice that we are able to travel from country to country, but as a result, we do spread the disease. And this is why we're in a pandemic now with the COVID-19. And the reason why it has spread so quickly is that people have been traveling internationally and even within the states. WHO is, again, it's the World Health Organization that we've talked about earlier, and they're concerned about influenza pandemics. Throughout history, influenza pandemics have killed large numbers of people. In 1918, the Spanish flu killed about 2.6% of individuals who contracted it, and that was more than over 40 million people. Bird flu, which is the H5N1 virus, and it's present in Asia and other countries. And it has devastated bird flocks. And it has appeared in humans due to contact with infected poultry, and humans can pass it on. There's also the H1N1. In 2009, there was a new virus, and it is a respiratory infection. It's also commonly called the swine flu. And the swine flu, of course, is found in pigs and can be transmitted to humans. So this has affected fairs and how they present their pigs. I know in 2009 it was pretty big. The pigs were tested for the swine flu before going into the fair. And I'm pretty sure that is when they started putting the hand sanitizer at the door so people can use it as they go in and as they've left. And during that year, I'm pretty sure right after the kids showed their pigs, they were transported out of the fair. It spreads quickly and easily between humans when infected people cough or sneeze and others breathe in the virus or come in contact with contaminated surface. And the H1N1 has spread to all parts of the world. So that was in 2009. There's also been an epidemic of the Ebola virus disease, as occurred in West African countries. More than 23,000 people have been infected, and more than 70% of those died. So that's a high percentage of those who died. According to those, 70% is a high percentage. Fruit bats seem to be the natural host of Ebola viruses, and it spreads to humans after close contact with blood, secretions, organs, or body fluids of animals such as fruit bats, monkeys, chimpanzees, and gorillas who are infected. So in West Africa, they may eat some of these animals, and so once they eat them or come in contact with them after they're killed, then they become infected, or an animal might urinate in an area or on a fruit, and then somebody comes around and picks up that fruit and eats it. That's another way people could be infected. It starts with flu-like symptoms that gives way to severe diarrhea and vomiting. Then external and internal hemorrhaging occurs, and more major organs fail. So hemorrhaging is bleeding starts. So is that pleasant to get for sure. The Ebola is a highly infectious virus and is spread by direct contact with blood, secretions, or bodily fluids of infected animals. In September of 2014 was the first case in the U.S., and that was when a person traveled from Liberia to Texas, and unfortunately the individual died even with intensive treatment. There were 2 nurses who provided care to that individual, and they were also diagnosed with it, but they were both able to survive. More cases have developed in healthcare personnel who have provided care in West Africa. Ebola has been in the U.S., Spain, Britain, France, Germany, Norway, Switzerland, Italy, and the Netherlands, so kind of all over the place. WHO began coordinating the construction and staffing of treatment centers in the highly infected areas, and providing education on this disease. Centers for the Disease Control and Prevention has issued very strict transmission-based guidelines that must be followed when providing care. So therefore, the U.S. has set guidelines as to infection control guidelines so that it's not spread and other people don't get it. By 2015, the epidemic was under control, but a pandemic may still occur in the future. There is concern that flu viruses can mutate quickly and may create a new and even more lethal virus. So with the flu, each year, a vaccination is made for the flu, and they make the vaccination according to the flu virus that they think is going to be the most prominent or the most relevant for us to deal with. But there are thousands and thousands of different kinds of flus, so even when you get a flu shot, it does not cover all strands of the flu. Viruses are prone to mutation and exchanging genetic information. The creation of a new and lethal virus can occur at any time. This is the case with COVID, and I've even heard that since there has been COVID cases that the virus has mutated. Which, once it mutates, it makes treating it very difficult because what might have worked for it in the beginning may not work for a virus later on. WHO estimates that 2 to 7 million people worldwide could die from infections caused by this type of virus, or even tens of millions of people could die. For pandemics, governments are creating pandemic influenza plans to protect their population. They can include education, vaccine production, antiviral drugs, and the development of protective public health measures and international cooperation. And we're going to discuss each of these. Education. Information about the pandemic and ways to avoid its spread must be given to the entire population. So just like when the COVID first started, there was a big push on washing your hands and how to wash your hands. Some said to wear masks, others said not to wear masks. I've heard it said that if you have good doses of vitamin D and vitamin C, then it helps also prevent you from getting COVID-19. If that's completely true, I'm not for sure. But the populations have to be educated on how to avoid getting it. A vaccine production, more research must be directed toward producing effective vaccines in larger quantities in a shorter period of time. So just like the flu vaccine, there are some employers, mostly healthcare employers, who may require their employers to get a flu vaccination, whether their employee really wants to or not. And that might be something you think about when getting a job, whether you like to get the flu vaccination, you may not like to. While you're at the interview, you may want to ask, is it a requirement to get the flu vaccination? Because that may or may not affect whether or not you want to take the job. Memorial Hospital, I'm pretty sure, requires the flu vaccination. The Veterans Hospital in Ann Arbor requires employers to get the flu vaccination. So something to think about. And right now, there's been talk of the COVID vaccination. And some questions people have been asking, is it going to be a requirement for people to get the COVID vaccination? And should the government be allowed to require everybody to get the COVID vaccination for the greater good, whether you agree with it or not? Another issue might be, will students who are in public schools be required to get the COVID vaccination? Some people may want to get the COVID vaccination, others may not. They may not want to because there's no long-term studies that will have been done on the COVID vaccinations. So in 5 years, will there be any side effects from getting the COVID vaccination? 10 years down the road, will everybody who gets the COVID vaccination maybe come down with a certain cancer, or maybe it'll mutate their genes and affects their babies that they may have in the future? So there's all kinds of questions on long-term effects of the COVID vaccination. Might be an interesting question to ask your parents. If the COVID vaccination does come out, will they have you get it or will they not get it? And ask them what their reasonings are. Antiviral drugs. Drugs that are currently available must be stockpiled so they'll be ready for immediate use, and more research must be done to develop and produce effective antiviral drugs. So the governments are trying to get these antiviral drugs available so that they're easily available and quickly available if a pandemic occurs or when the pandemic occurs. There's the development of protective public health measures. Influenza must be diagnosed rapidly and accurately. Strict infection control methods must be implemented to limit the spread of the virus. First responders and healthcare personnel must be immunized so they will be able to care for infected individuals, and quarantine measures must be used if necessary to control the spread of the disease. So the flu is many reasons why in the winter when it's flu season, the assisted care facilities or nursing homes, one, they may be either shut down completely to no visitors, or they may limit to visitors to those who are 18 or even 21 and older. Same thing with the hospital. They may limit the age of visitors who come, or they may limit visitors completely. International cooperation. Countries must be willing to work with each other to create an international plan that will limit the spread of lethal viruses and decrease the severity of a pandemic. So during this pandemic, have countries been working together? I don't know. Some say they do, some say they have, and some say they haven't. There's also drug-resistant bacteria or superbugs. MRSA is one of them. CRA, MRAB are all believed to be caused by decades of unnecessary antibiotic use. So when I was younger, people would go to the doctors. They had a cold or they had a sore throat. They were almost always given an antibiotic. So overuse caused genetic mutations in bacteria that made them resistant to commonly used antibiotics. So, from my generation, when I was younger, people got antibiotics quite often when they probably weren't needed. So, as a result, the bacteria in the bodies have mutated and changed so that the antibiotics do not affect them anymore, which makes it very difficult to treat now. Also, something else that can cause genetic mutations is when a doctor does prescribe an antibiotic and when it's needed, and the doctor says take it for 7 days, and the person feels good after 4 days, they stop taking it. So again, that bacteria could become resistant to the antibiotic. For pandemics, there's much effort will be directed toward identifying and limiting the effect of any organism that could lead to a pandemic. Healthcare workers must stay informed and be prepared to deal with the consequences. Cooperation must be a global effort. So going back to healthcare workers, there are many healthcare workers during COVID-19, especially in the beginning, where they might have stayed in a hotel, or they might have stayed in a trailer on their property, or they might have social distanced and quarantined once they got home in order not to get their family sick. Many will go in the garage and maybe change their clothes and put them directly into the dryer, the washer, their work clothes. They may wash their shoes, have shoes that are only kept for work, in an effort not to spread it and not to get their family sick. So you can finish the work on your workbook. So biotechnologies is the use of genetic and biochemical processes of living systems and organisms to develop or modify useful products, or as defined by the UN Convention on Biological Diversity, as a technological application that uses biological systems, living organisms, and derivatives thereof to make or modify products or processes for specific use. So we're going to talk about the biotechnologies more. They've been used for thousands of years in agriculture, food production, energy, medicine, and other fields, as expanded and will continue to expand to include new and diverse sciences. It can include genomics, pharmacogenomics, proteomics, stem cell research, and nanotechnology. So genomics is genetic testing, the use of specific tests to check for the presence of inherited genes known to cause disease. Many genetic tests have been developed. The tests allow preventative methods and/or early diagnosis to eliminate or decrease the effects of the disease. It's available for cancers, osteoporosis, and AIDS, and prenatal screening for cystic fibrosis, sickle cell anemia, and Tay-Sachs. So, a couple things with genetic testing. If somebody knows they have a hereditary disease, they could go in to be tested to see if it's likely that they would pass it on to their children. They could then decide if they want to have biological children, or maybe adopt or foster, or maybe not have children at all. Something else they can do is once there's already a fetus, they could do prenatal screening and check to see if that fetus is prone to a genetic disease. And once that happens, then the couple or the mom decides will they go on with the pregnancy or not. This is very controversial. It would, for some, it's an ethical consideration. Prenatal or abortion. Some are for abortion, some are not for abortions. So it's things to think about. And another thing is, would you like to be tested to see if you're going to maybe have osteoporosis? Or would you like to be tested to see if you're going to have Alzheimer's? Maybe at 30, you can be tested to see if you're going to have Alzheimer's. Are you going to live your life differently if you know you have Alzheimer's? And then the other thing is, when will you start having symptoms of Alzheimer's or Parkinson's? Will you have symptoms when you're 30 or 40, or maybe you won't have symptoms until you're 80 or 90? So again, questions that people ask. Do they want to know they're going to have a disease or a condition later on in life, or do you just want to live your life, and if it comes on, then it comes on? Pharmacogenomics is using a person's genetic makeup or genome to choose the drugs or drug doses that are likely to work best for that individual. It's based on recognizing that individuals respond differently to medications according to their genetic makeup. The hope is to provide precision or personalized medicine in which medication and dosages is optimized for each individual. So we all know everybody is different. Everybody reacts to a medication differently. You may have one person who takes a medication for 10 years and has had no issues. You may have another person who takes the exact same medication once or twice and they have an allergic reaction, or they have another side effect from the medication. So during the pharmacogenomics, it is tailored to that one individual person. So another question to ask, is this expensive? Definitely expensive. Does insurance cover it? I don't know. It may not cover it. So if that's the case, is this equal care for everybody? Is everybody have access to pharmacogenomics, or is it only those who have insurance that will cover it, or maybe those who have that financial ability to cover it? Research is directed toward developing drugs for specific targets identified through genetic sequencing. It leads to more accurate and effective treatments for many cancers and other diseases. The targeted drugs would decrease adverse reactions or side effects, provide accurate dosages based on how the individual body metabolizes the drug, and treats the disease area while limiting damage to nearby healthy cells. In the case of, let's say, chemotherapy. Chemotherapy, unfortunately, does not only attack the cancer cells, but it attacks healthy cells too. It's very difficult for people. People lose their hair, they get sick, other conditions may start as a result of the chemotherapy. So that would just be so great to have a medication that will only target the cancer cells and not the healthy cells. Proteomics studies the structure and function of the proteins. So proteins are very important to our bodies. They are substances in the protoplasm of cells that cause biochemical reactions. They act as messengers. They influence growth and development of tissues. They transport oxygen in the blood. They defend the body against disease. They regulate cell reproduction, and they perform many other vital functions. So proteins are very important. They have a lot of jobs to do. So research is directed toward mapping a proteome, or the entire set of proteins produced or magnified by an organism, similar to the way genomics maps the human genome. When research identifies the defective proteins that cause specific diseases, new drugs can be developed that correct a defective protein or replace a missing one. They may find biomarkers that identify unique patterns of proteins to diagnose diseases. So again, this may be, some people may agree with this, some people may not agree with this. You may find biomarkers that identify the unique patterns of proteins to diagnose a disease. Again, do people want to know early on that they're going to have a condition or a disease later on in life? Stem cell research studies stem cells, or cells that are capable of becoming any of the specialized cells in the body, such as skin, muscle, or nerve cells. There's two main types. There's the embryonic stem cells from a developing fetus. So once you have a fetus, all the cells keep multiplying, and then they become specialized. So some cells will become skin, some cells will become muscle, and there's also somatic or adult stem cells. Research is directed toward determining how the cells continually regenerate as stem cells or change structure to become a specialized cells with specific functions. Again, this is another ethical issue for some people. Some people agree with stem cell research, some people don't. There's been a lot of research in stem cell research in regards to paraplegics and quadriplegics. So again, should you be studying cells from a developing fetus? The hope is to replace the defective cells and to treat diseases. Nanotechnology uses a wide range of techniques to manipulate atoms and molecules to create new materials and devices. Nanomedicine is the use of nanotechnology for medical applications. So a nanometer is very, very small. It's like 1/1000th of a meter. So in the book, they describe it as, think of the nanometer as a marble and then the meter as the world. So as you can see, the marble in the world would be very, very small and minute. Nanotechnology has led to the development of nano devices that can deliver drugs in precise amounts to the targeted body cells. This again decreases the side effects. So the drug is going exactly where you want it to. It's not going to go and attack healthy cells. Tissue engineering is attempting to use nanotechnology to build structures that repair or reduce damaged tissue. Again, this can be an ethical concern for some people. It has the potential to replace organ transplants or artificial implants. So is it okay to recreate and make organs? There's numerous people, lots of people who are on the organ list who are waiting for organs, and they're not able to get an organ until someone dies. So again, is this okay to do? Everybody's views are differently with this. Neuroelectronic research is directed at using nano devices to link computers to the nervous system to treat paralysis and nerve damage. Has led to the development of diagnostic devices, contrast agents for imaging, energy-based treatments using heat and radiation, and biosensors that measure very minute amounts of substances in the biological fluids. Biotechnologies will have a major impact on the future of medicine. Opportunities in this field are unlimited, and many new healthcare careers will develop as research continues. But it also has created a lot of bioethical concerns. Example, should a human be cloned using biotechnology? A lot of debate has gone on over this. And it will continue to be a concern as these sciences advance. So that is all it for Chapter 1. If you have any questions, be sure to let me know. Have a great day.